Institute of Technology, Kurukshetra. With a PhD from Jawaharlal Nehru University, he has been doing wonderful work in machine learning, sensor, wireless sensor, network and data analytics. Dr. Gupta has made significant contributions to the field authoring number high-impact journal and conference publications. Today, he will be sharing his insight on modeling and classifying dialects using Python. And we are very thankful that Sir accepted our invitation and accepted to give his expert lecture or a session for day two. Please join me welcoming Dr. Kapil Gupta. And sir, the mic is yours, and we wish that you will convey your session by 7:10 so that we can have ample time for question and answer session, sir. Thank you, sir. Kapil, sir? Okay, sir is typing. Make him hold so that he can open his mouth. So we are just doing that.
Sir, yes, sir. Yes, sir. Kindly try now, sir.
And, thank you very much, Prati ma'am and Ashish sir. Thank you for providing me this privilege to talk to your audience, and thank you for such a nice introduction. I believe that this session will actually help us conserving our own legacy of such a rich legacy of languages, dialects, because in India we have so many different languages, so many different accents, so many different literature available in various things, various part of our country, that we cannot leave it just like that. And there is a challenge also, and so by that mean I would really thank Poornima Institute for actually proposing such a wonderful topic and coming up with this idea that we should do this kind of work. So congratulations to you all, and let me start my this presentation. Maybe I can share it with you. While doing or having this presentation, let me feel you comfortable that please ask me anything wherever you want. Do make some kind of intervene there, then and there, wherever you feel like, okay, we want some questions or we want to have something to be clarified, please ask me. Feel comfortable. And this session, as I discussed with Dr. Ashish also, we will be maintaining a little bit of Hindi and English. And wherever you feel that, okay, I should a little bit more talk about in Hindi or something, we can do that. Thank you. Let me start. Okay. So is this my screen is visible? Is my screen
Yes, sir.
visible?
Yes, sir. Visible, sir.
Okay, thank you. So our topic of the ATAL workshop is on preserving local dialects using multi-layer perceptron on sustainable development of communities. So let me just try to take a few minutes to ponder on this topic. So local dialects, as I already told you, like we have such a variety of languages and dialects that we want to preserve it. And why we want to preserve it? Because our youth is actually speaking this dialect. हमारा जो नौजवान पोर्शन है यानी कि लोग हैं वो लोकल डायलेक्ट्स को बोलते हैं। ये बच्चे यदि लोकल आवाज़ों में या लोकल भाषा में अपनी लैंग्वेजेस में स्टडी करेंगे, पढ़ेंगे, तो ज़्यादा बेहतर तरीके से पढ़ पाएंगे। और उससे भी ज़्यादा शायद ये कि हमारी आसपास की जो समस्याएं हैं, यदि वो समस्याएं हमको अपनी भाषा में कोई समझाने वाला मिलेगा, तो शायद इससे बढ़िया कुछ और हो नहीं सकता। So I feel that there is a seamless communication that can be given through the technological intervention by preserving local dialects. We can also provide a wonderful educational system which actually delivers the things in in the local language, in the native language. The child is learning throughout his life. If he does that, he will be able to understand the things in a very normal way, in a very natural way. So, okay, to justify my topic, the topic is on modeling and classifying dialects. So let me just try to ponder the words modeling and classifying. So modeling means you have a certain aspect of something and you want to put it into a frame where only you take only those important things which are relevant to your objective. So whenever you want to model something, let's suppose you are working on a transport problem, then you take only those aspects of the transport which are relevant to your problem and leave all the other things aside. So this is called modeling. And classifying is again classifying on various bases. So let's try to understand what does it mean by classifying dialects. So one meaning could be we want to identify which dialect this particular thing is, or this particular language, जो भी आपके सामने language बोली जा रही है, उसका actually language क्या है, उसकी dialect क्या है. So am I audible? And is there any?
Yes, sir. Yes,
Yes,
sir.
please.
There are things is coming, so I thought like maybe some issues may be there. Okay, so classifying dialects is majorly dependent on understanding that what kind of things we want to classify. So one thing is we want to identify the language. Another thing could be I want to identify the word that you have spoken or the audio has played for. Another thing could be like accent. Another thing could be the emotion. So there are so many different uh, aspects that one can classify upon. So modeling and classifying dialects may actually mean all these. So while modeling this, we need the data which is relevant to this classifying objective. Now this data is nothing but features. We will talk about what exactly feature is in this perspective, and then we will be talking about how to select the right features. So all different kind of algorithms, why we are actually selecting the features, what is the objective of feature selection, all this kind of thing we are going to talk about in this particular presentation. So I hope this gives you a good background about what PPT, what presentation you are going to see in next few hours. Okay. Any questions if you have, please ask. So the outline is already we have discussed. Okay. What are features, how to collect them. Then once the feature selection stage is coming, what is feature selection, why we need it, and how are we going to select them. Okay. So before going ahead, is there any question?
Any question from the participants? Sir, no question, I think, right now.
Okay, okay, thank you. So what is a feature? When we want to describe a particular thing, a particular sample. So for example, in our case, we are trying to describe a audio clip. Now, while we are describing this audio clip, we can utilize so many different things, like what is the volume, what is the pitch, what is emotion in that, if at all you can find out. So there are acoustic features, there are other features, and these features may or may not relate to the classifying of the different ideas, or classifying the audio clip in different ideas. Like, as I said you earlier, maybe you want to identify which language it is, which emotion, which accent, or which word. So all these kind of classifications, the features should be relevant to classify that particular thing. So first of all, we will select some features, we will get some features, because initially we have a raw data. Raw data means that audio clip, that is called raw data. So let me just give you an example once again with a simple thing. Like, you have a CPU and you want to describe it. You might use a number of parameters, like its height, width, color of chips, number of PCBs, weight, number of hard disk, type of hard disk, and so on and so forth. But and in our case, as we talked, these are the some features that we want. So there could be spectral features. You might have some frequency, the audio frequencies, and you want to catch up the frequency changes and the next frequency that is coming. All those different kind of things you might want to capture. The duration of the features you want to catch, and there are other features which are more importantly can be discussed in some other presentation. But as of now, we are more towards, once you get the features, how to select them. So let's come back to our previous example. Like, we have a CPU and we have so many features. But now I have an objective. I have an objective to buy a particular CPU. Now, when I am going to buy a particular CPU, it might not be relevant to discuss about height, width, color of chips. They might not be relevant. The relevant features could be like the type of hard disk, the size of hard disk, the RAM size, RAM speed, and so on and so forth. So not all the features are actually important, right? Since all the features are not important, I want to reduce or remove those features. So there are two type of features that can be removed. One is they are not providing relevant information. The another one is they can be derived, they can be attained from the left out features. So if some feature can be utilized from other features, this is a redundant feature. So I just want to remove it, because keeping a redundant feature actually brings some other problems. So what are the features? So if we go to the feature selection, so the question is, what is feature selection? Why we want to do it? And how we will do it. So first, let's talk about feature selection. So feature selection primarily focuses on removing non-informative or redundant predictors. So here comes one terminology. एक टर्मिनोलॉजी है, वो क्या कहती है? प्रिडिक्टर क्या होता है? प्रिडिक्टर वो सारे डिस्क्रिप्शन है जिससे आप सीपीयू की कॉस्ट पता करना चाहते हो, जिससे आप ये पता करना चाहते हो कि आप क्या शब्द बोल रहे हैं, या किस एक्सेंट में बोल रहे हैं, या किस इमोशन में बोल रहे हैं. तो देयर आर सर्टेन फीचर्स ऑफ द ऑडियो क्लिप, एंड देन देयर इज अ टारगेट. सो प्रिडिक्टर्स क्या है? वो सारे डिस्क्रिप्शंस हैं उस ऑडियो क्लिप के, जिससे ये चीज बताई जा सके कि उसमें इमोशन क्या है, वो शब्द क्या बोला जा रहा है, किस डायलेक्ट में बोला जा रहा है. ये सब टारगेट एट्रीब्यूट होंगे. प्रिडिक्टर्स कौन से होंगे? जो ऑडियो क्लिप की एट्रीब्यूट्स होंगे, जिनकी सहायता से आप टारगेट एट्रीब्यूट को पता करेंगे. सो आई होप predictor, the term predictor is very clear. If there is any question, please do ask the host, Dr. Ashish or Dr. Krati. We will take it up as soon as possible. Okay, so it's Once again, let me just try to catch it that there's a very much clear distinction from feature selection and feature extraction. So what is feature selection? Feature selection is about selecting the features. And what is feature extraction? The feature extraction is something where you have a raw audio clip and you want to infer some of the ideas out of it. So like pitch, you will be not getting the pitch from the raw audio file. The raw audio file might be giving you the timestamp and the volume, right? Pitch. So there are very few things given, and out of that, you want to actually extract some features that are relevant uh, to the prediction of or prediction of the emotion, prediction of word, and so on and so forth. But once you have extracted those features, you now want to identify what are the features which are relevant to your objective. Okay, why we need feature selection? So there is a good reason. There are really good number of reasons. So the first reason is the dimensionality of input features. We will come back to this particular issue once again. Uh, let's go to the next one, the noise in the data. So when we reduce the features, the noise automatically reduce. Why I say so? Because what happens is that when you are uh, getting the data, recording the data, there is always some noise. So if there are features are more, then automatically with each feature there is some noise is associated. Maybe because your sensors are little bit uncalibrated or wrongly calibrated. Maybe sometimes there's a manual error while recording them. ऐसा कुछ भी हो सकता है जिसकी वजह से मतलब आपने रिकॉर्ड करते हुए कुछ गलती कर दी या आपके सेंसर खराब थे इस वजह से हो गया. सो देयर कुड बी अ नंबर ऑफ रीजंस, बट समवेयर हर फीचर के साथ कुछ ना कुछ नॉइज जरूर होगा. तो यदि हम फीचर्स कुछ कम कर देते हैं तो नॉइज भी ऑटोमेटिकली कम हो जाता है. दूसरा क्या है कि कोई भी मशीन लर्निंग एल्गोरिदम जो होगी वो उसमें नंबर ऑफ फीचर्स यदि आप लेंगे तो वो या स्टोरेज स्पेस तो लेंगे ही लेंगे, साथ में कंप्यूटेशनल रिसोर्सेज भी उन्हें डिमांड करेंगे उसी ऑर्डर में. सो इफ आई रिड्यूस दोज फीचर्स, मेरे कंप्यूटेशनल रिसोर्स यानी कि स्पेस और टाइम दोनों बचेंगे. सो विच इज अगेन रिक्वायरमेंट व्हेन आई एम रिड्यूसिंग द फीचर्स. एंड अगेन when I'm going for classification, यदि मेरे पास कम features होंगे, if I have small number of features, what will happen? Only the result, the model that I get, it is more comprehensible. I can understand which particular feature has more importance over other. So this comprehension will be easy in case of less features rather than if I have, let's say, thousands of features. Now, the first this issue, the dimensionality of input feature, is actually turns out the curse of dimensionality. And this is one of the biggest reasons why we have to or we should reduce the features. Although the deep learning itself minimizes by forcing to have most of the weights to be zero. So if I do that, I am actually trying to find out more and more important features only, and the less important features to be removed out. But for the sake of understanding, let's try to understand why this curse of dimensionality. What is this curse of dimensionality? So, in a simple statement, if I say,
Excuse me, sir.
please, yes.
Sir, there is one query from Apurva Bansal. Sir, sometimes we have the vector of features that can generated from the dialects by any NN model. Then
Okay.
how we can select relevant feature? Secondly, how we can conclude theoretical about the features category that is extracted by the neural network model in the form of vector, as it is all numbers in the vector.
Okay, so we will be going to discuss that only. So maybe during this presentation, I may be able to take it again. Uh, uh, Ashish sir, can you put this query on this? Yeah, here I think it is there. Okay, fine. Let me read it once again. Sometimes we have vector features that can generated from dialects by neural network model. Then how we can select relevant features. Secondly, how we can conclude theoretically about the feature category that is extracted by neural network model in the form of vectors, as it is all numbers vector. Yeah. Thing is like there is something called embedded systems or embedded methods of filtering the features. So we will look at that, and you might focus on those things later on. Although we will not be covering it in detail, but the idea is simple, that we want to penalize all the features. So the number of features are penalized, which means that we ask the neural network to shift to lower set of features that are contributing in some way. So we will see how we can ensure that the contribution is coming, the quantity of contribution. We will also check it out. And once we see that how to identify the contribution, we will try to minimize that contribution, or not minimize the contribution, but minimize the number of contributing features. So once we minimize the number of contributing features, we are definitely reducing the features itself. So that's the way we do it. So even if it is numbers, we are able to identify, we are trying to ask the model itself to reduce the number of features. Is that answers your question, Apurva? Okay, let's come back to our presentation. Okay, let's try to understand what is curse of dimensionality. So we said like जैसे जैसे डायमेंशंस इंक्रीज होती हैं, डायमेंशन क्या है, डायमेंशन नंबर ऑफ फीचर्स है. जैसे जैसे आप फीचर्स को बढ़ाते चले जाते हैं, डेटा पॉइंट्स की दूरी आपस में बढ़ती चली जाती है. जस्ट फॉर एग्जांपल, इफ यू टेक you consider a room or a square. So if you take the maximum distant points, so it comes out to be on the diagonally opposite edges. And if it is 1 unit square, then it is root 2. But if you go for a cube, what is the largest distance between the 2 points? Can somebody estimate it? The largest distance between the 2 points in a cube of unit 1, of side 1. Can somebody tell me? So this is 1, this is 1. The diagonal ones is 1 square plus 1 square and root of that, sum of root of that. So that comes out to be root 2. Now, if you consider a cube of again 1 unit, so on the z direction there is a height of side 1. So square of this thing plus in the z direction 1. So 2 plus 1, 3, and the Pythagoras theorem, with the help of Pythagoras theorem, if I try to find out the diagonally opposite two corners of a room, so that goes to under root 3, which is larger than under root 2. So you can see that with the increase in dimension, with the increase in features, the distance between the points is actually increasing. Let's take it more intuitively. Consider one more circle. Now, any point within the circle is more closer than the points lying in the corners of this square. Am I right? Is that clear? So average distance between points lying within the circle will be closer. So any 2 points, if you take it only inside the circle, they are definitely closer, because if you go outside, or consider the outside world also. So this red also, then it will become larger, right? Okay. So let's try to take further look. This is the curve that tells us the volume of hypercube or the cube in higher dimensions. So if it is 2, then it's a square. If it is 3, then it's a cube. If it is 4, it's a 4-dimensional cube, 5-dimensional cube, 6-dimensional cube, and so on and so forth. Now you can see as soon as you even cross 12, your volume of the cube is goes in the order of thousands. Yes. Is somebody asking any question? Okay. I think I should go ahead. And if you consider the circle in case of dimension 2, so this is enclosing circle. So you have a square, and inside that square there is a circle. So if you see it, the order of the volume of this sphere is not beyond 6 even, while this is actually going in thousands, tens of thousands, which is really huge. So the points lying within the circle will be very few. So most of the points are actually lying in the edges. So here in corners पे ही सारे आपके points lie करेंगे. If you are putting all the points in these corners, they will be highly distributed. एक दूसरे से बहुत ज्यादा दूर होंगे. और मशीन लर्निंग जो एक बहुत इंपॉर्टेंट कंसेप्ट है मशीन लर्निंग में, किसी भी चीज को सिमिलर कहने का, वो है सिमिलैरिटी बाय डिस्टेंस. हम डिस्टेंस निकालते हैं, और डिस्टेंस यदि दो सैंपल्स के बीच का डिस्टेंस, मान लीजिए कि आपने एक ऑडियो क्लिप ली है, ऑडियो क्लिप के आपने एट्रीब्यूट्स निकाल लिए, उन एट्रीब्यूट्स के सिमिलर होने पर हम कहते हैं कि ये दोनों ऑडियो क्लिप ऑलमोस्ट सेम है. ये दोनों ऑडियो क्लिप में जो वर्ड बोला जा रहा है वो सेम बोला जा रहा है. इन दोनों ऑडियो क्लिप्स का जो इमोशन है वो सेम है. सो जो आपके फीचर्स हैं, उन फीचर्स के आसपास होने से, यानी कि उनकी वैल्यूज आसपास होने से हम ये बात कह पाते हैं कि वो आपस में सिमिलर है. और यदि उनकी जो डिस्टेंस है, यूक्लिडियन डिस्टेंस, यदि वो ज्यादा बड़ा आता है तो हम कहते हैं कि ये दोनों एक दूसरे से काफी अलग हैं, डिफरेंट हैं. सो ये एक बहुत क्रूशियल कंसेप्ट है. मशीन लर्निंग में जब हम किसी चीज को सिमिलर बोलते हैं तो हमें उसके लिए डिस्टेंस चाहिए होता है, और यदि सारे डिस्टेंसेस बड़े बड़े हो जाएं तो हम किसी को भी सिमिलर नहीं बोल पाएंगे. That is where the curse of dimensionality comes into picture. And that's why we want to reduce the dimensionality, the number of features in our example or in our case. So that's is the thing. Is there any question?
Excuse me, sir. Yes, sir.
Yeah.
Mrs. Sukeshi Roy has raised her hand. So,
Let me.
Sukeshi ma'am, do you want to ask anything? Sukeshi ma'am?
All the participants are requested to write their question in the message box, which makes it easier for me to understand also. Sometimes there is a network lag and something which doesn't help us to understand. Yes, Sukeshi ma'am, please speak up. You can write.
Maybe she unknowingly raised her hand. So
okay. So let's go back. If there is any other question regarding curse of dimensionality or anything else. Okay, let's go ahead then. She's again putting his hand up, raising her hand.
Yes, sir. I think unknowingly it has been
okay. Raised. So let me continue with my presentation, and I request all the participants to please put the message that makes everything easier for everyone. Okay. So let's go ahead and we want to understand how to resolve this thing, how to filter the features, how to get the important features that are important to our task. So there are three kind of methods: the filter method, the wrapper method, and the embedded methods. Uh, what Apurva was asking, or Apurva madam was asking, those things or those methods come under embedded methods. So we will discuss one by one each of them. So first of all, filter. As filter suggests that we want to identify some important features based on some criteria. And what's that criteria? Let's try to understand a concept called correlation. Correlation, do not go with the exact formula for the correlation. Let's try to understand the meaning of correlation. Correlation means one particular feature is dependent on another feature. One particular feature can tell you some information about other feature. So for example, if you have if you have, let's suppose, weight and volume, you can determine density, right? So weight and volume determines density. So if all these three columns are there in your data, then density may be removed, right? You don't need it because it can be derived from volume and weight. So such correlations should be identified, and if these correlations are not required, they should be removed. When they are required, the next question comes like that. Of course, they might be required when you are actually, your target attribute itself is density, then it is required. But if the target attribute is not density, you are putting density as a feature to predict something, then there's a problem. You are already having more than enough information, right? So you can drop density and you can take volume and weight and continue with that. So this is the reason why we can find out, we try to find out correlation between the features. And once we find out the correlation between features, if they are predictors and having good correlation among themselves, we filter some of those highly correlated features and keep other features. So one of them can be removed. One of them can be kicked out from the set. But if they are having a good correlation with the target attribute, then we may want to keep it. So, and there is another one. If there is an attribute which does not have any variance, which does not deviate, it is constantly 1, 1, 1, 1, 1, or some 2, 2, 2, 2, 2, then it does not convey any meaning, right? So such kind of attributes can be rejected. So if you see, here it is. If the variance is greater than something, we can keep it. Otherwise, we can reject it. If the correlation between the features, the predictors, is less than threshold, so if it is very good correlation, then one feature can be determined by other features. If it is determined by other features, then there is no need of such a feature. So the features in set S are sufficient, right? So in that case also, if it is going beyond the threshold 2, above threshold 2, we may want to reject it. We want it to keep it only if it is less than some threshold. But if it has a good correlation with the target attribute, we want to keep it. So with these ideas, we can go ahead with the statistical methods, the filter methods. So the largely all the filter methods utilize some or other correlation formula or thing. So let's see what are the different correlation quantifying ideas. So the correlation can be calculated with numerous ways by considering type of input, output feature, and type of relationship. So let's see what the null space. Correlation coefficient, Spearman coefficient, Kendall coefficient, chi-square test, and there are actually many more. So the correlation coefficient, you have already know it very well. We are not going to look at a lot of formula here, but let's just look here. What comes out? So if this is one of your variable, this is another variable. Let's say suppose this is x, this is y. And if your data looks like this, the scatter plot of your data looks like this, the correlation comes out to be very good, that is +1. This is the value of correlation coefficient goes from -1 to +1. So maximum it is +1 and minimum it's -1. It cannot go beyond that. So if you can see, there's a very nice linear relationship we can observe. So if there is a very nice linear correlation, it comes out to be +1. If the data seems to have a linear correlation or linear relationship, so because you can see if x is high, the value of x is high, so the y value is also high. For every data point in this cluster where this x value is high, y value is also high, relatively high. Here the cluster is little bit more diffused, ये ज्यादा फैला हुआ है, scattered है, और इस कारण से इसका कोरिलेशन देखिए कम आ रहा है. हालांकि इसमें भी कहीं ना कहीं आपको एक बैंड सा दिख रहा है, जो बैंड आपको ये बता रहा है कि यदि छोटा हम लेते हैं, कम हम x की वैल्यू पे बात करते हैं, तो y की वैल्यू भी कम है. यदि हम यहाँ पर y की वैल्यू के ऊपर बात करें तो y की वैल्यू जनरली ज्यादा आ रही है. ठीक है, तो यहाँ पर पॉजिटिव कोरिलेशन है, बट वीक हो रहा है, धीमे धीमे वीक होता जा रहा है. यदि यही चीज x के बढ़ने से y डिक्रीज हो रहा है, x बढ़ाया हमने, y डिक्रीज हो गया, y की वैल्यू इसके पॉइंट के अगेंस्ट ये आ रही है, सो x ज्यादा है, y कम है, तो उस केस में नेगेटिव कोरिलेशन आता है. और यदि आपको ऐसा कोई ट्रेंड नहीं दिखाई देता तो जनरली कोरिलेशन 0 चला जाता है. सो दैट्स द रफ आइडिया अबाउट कोरिलेशन कोफिशिएंट. Is again Spearman rank coefficient. So basically let me just clear about it. कोरिलेशन कोफिशिएंट तब यूज करते हैं जब आपके पास में जो डेटा होता है वो रियल वैल्यूज लेता है, न्यूमेरिकल वैल्यूज लेकर के बैठा होता है. सो देन ओनली वी कैन यूटिलाइज कोरिलेशन कोफिशिएंट. वी शुड नॉट यूटिलाइज कोरिलेशन कोफिशिएंट व्हेन यू हैव कैटेगोरिकल डेटा, डिस्क्रीट डेटा. न्यूमेरिकल डेटा होता है तो वहां पर ज्यादा अच्छा रहता है. लेकिन कई बार ऐसा भी होता है कि हम रैंकिंग देते हैं. So this is first, this is second, this is third, this is fourth, and so on so forth. So ऐसे रैंकिंग डेटा के लिए स्पीयरमैन रैंक कोरिलेशन कोफिशिएंट या कैंडाल कोफिशिएंट बेटर रहता है. कैंडाल छोटे उस पे काम करता है, लिटिल डेटा पे, जहां पर काफी ज्यादा रैंक सिमिलर सी होती हैं, तो वहां पर कैंडाल काम ज्यादा करता है. अदरवाइज यू कैन यूटिलाइज स्पीयरमैन रैंक कोफिशिएंट. Then comes the null space. Null space एक बढ़िया सा एक आइडिया है. आइडिया क्या है? हम ये देखते हैं कि ये हमारे पास में एक फीचर्स हैं. सो दिस इज सैंपल 1. एवरी रो इज रिप्रेजेंटिंग अ सैंपल. सो A11, A12, A13 अप टू A1n, ये एक सैंपल को बता रहा है. आपने कोई एक ऑडियो क्लिप ली, उस ऑडियो क्लिप को आपने इन डिफरेंट नंबर से, इन n डिफरेंट नंबर से रिप्रेजेंट कर दिया. ठीक है, सो इन n नंबर डिफरेंट नंबर से रिप्रेजेंट करने के लिए आपने इनको लिखा, और सेकंड सैंपल को फिर इस तरीके से आपने लिखा. सो A11, A12, A13, इनकी जगह एक्चुअली सम न्यूमेरिकल वैल्यूज आर कमिंग. ठीक है, सम न्यूमेरिकल वैल्यूज आर देयर. सिमिलरली A21 एंड सो ऑन, ये सेकंड सैंपल है, सेकंड ऑडियो क्लिप थी, ये mth ऑडियो क्लिप है जिसके बारे में आपने उसका डिस्क्रिप्शन इस तरीके से लिख दिया. नाउ व्हाट null space does? Null space tries to identify the linear relationship between the attributes. Linear relationship क्या होता है? So x1, so some real number times A11 plus some real number times A12 plus some real number times A13 plus some real number times A1n. ये चीज जो है हम एक दूसरे से निकाल सकें. So which means what? कि A11 की वैल्यू A12 से A1n, ये जितने भी एट्रीब्यूट्स हैं, इनकी सहायता से निकाली जा सके, एक लीनियर फंक्शन की सहायता से निकाली जा सके, जिसमें कि A21, A22, A12, A13, A14, A1n का यूज करके आप एक लीनियर फंक्शन बनाएं और उस लीनियर फंक्शन की सहायता से a11 को निकाल पाए। सेम लीनियर फंक्शन से आपने a21 भी निकाल सकते हैं, सेम लीनियर फंक्शन से आप am1 भी निकाल सकते हैं। यदि ऐसा कोई लीनियर फंक्शन मौजूद है तो वो नल स्पेस से पता पड़ जाता है। नल स्पेस अल्टीमेटली ये कहता है कि ये मल्टीप्लिकेशन करके जो भी आ रहा है ये सारा का सारा जीरो होना चाहिए, वेयर ऑल दी x1 x2 अप टू xn मस्ट नॉट बी जीरो। एटलीस्ट एक कोई जीरो नहीं होना चाहिए। इन जितने भी मल्टीप्लायर्स हमने यहाँ पर रखे हैं, x1 है, x2 है, xn है, इनमें से एटलीस्ट एक जीरो नहीं होना चाहिए, बाकी सब जीरो हो सकते हैं। और उस केस में हम रिलेशनशिप निकालने की कोशिश कर सकते हैं। वंस वी फाइंड आउट द रिलेशनशिप, we say that okay, that attribute can be kicked out because your attribute can be derived from other attributes. So that attribute is actually redundant attribute, non-informative. Redundant in the sense like it can be derived from others. Okay, then there is one more which is very crucial. I hope everyone have gone through this idea, the information gain or Gini index. So whenever we have built trees, decision trees, we might have used this idea. So if I have an attribute A1 and I know uncertainty about the attribute A1. Now, if this uncertainty can be reduced with the help of some other attribute A2, means that this uncertainty reduction is because of this A2. So if the uncertainty reduced is very high, you have reduced the uncertainty of A1 by a heavy quantity, then A2 is deriving A1 in some way. There may be a relationship between A2 and A1, and one of them can be rejected if both of them are predictors. If one of them is predictor, one of them is target, you want to keep them. So all these ideas can be utilized. So any idea which gives you this kind of information, okay, whether one attribute is dependent on other, could be a great thing to identify whether I want to kick out one of those attributes or not. Okay, there's another one, chi-square test. This is a statistical test wherein we are interested in finding out the distance between the square distance between the two values. So if you take corresponding samples, like for a particular sample, attribute 1 और attribute 2, दोनों की वैल्यू लेकर के उनको सब्ट्रैक्ट करके उनका स्क्वायर कर दिया जाता है, उसका सम लिया जाता है, एंड if this summation comes out to be very large, then both attributes are actually different. They are no longer agreeing each other. They cannot tell anything about each other, right? So if the chi-square test gives you a heavy number, big number, they might not be revealing about each other. They might be saying something else, and therefore they may be useful. But if they comes out to be near ones, if this chi-square is very small, then you feel that, okay, these two attributes may be dependent on each other. I can identify one attribute with the help of another one. And accordingly, you can think about that there is a correlation in certain way, right? So that's the thing. So any question related to the filter methods?
Yes, sir. I just want to know that the null space that you have explained, it is somehow based on the line equation. Am I right?
Yes. So it is linear equations. So you want to find out the linear equations. So there are vectors, and you want to say the linear combination of those vectors, can one of the vector can be represented by the linear equation of other vectors.
Okay, so the idea behind it, ki whenever the data is linear, so we can apply the line equation like a linear regression over it.
Right. So instead of going through the linear regression, what we do, we go for the rank of the feature matrix. Why?
Okay.
Because you cannot go over iteratively you need to go for iteratively, like for first feature, whether this feature can be find out with the help of other features. The second feature can be helped or can be find out with the help of other features or not. So you have to either go for iteratively, or if you don't want to go iteratively, what you can go do, you can go for the rank. The rank tells you, okay, these features are independent. So in fact, even if you go for the Gauss elimination method, I hope every one of you know the Gauss elimination method, or otherwise you can actually read it out more. If you go for the Gauss elimination, the pivot columns, the columns with the pivot elements, they tells you that those columns are independent and you can keep them. The others can be removed, right?
Okay, sir. Sir, one more question. Can you please elaborate a little bit about the entropy, like the difference between the cross entropy and Gini and where it is generally used?
Uh, the cross entropy, I feel, because I'm not in touch with cross entropy, maybe if you can a little bit elaborate once
Yes, sir.
for the formula.
Sir, it is a kind of a loss function that is generated in logistic regression in the end. We can generally say that
I
that
got it.
logistic regression loss function is the cross entropy. I
Right.
think so.
I got it. So what happens is that any kind of loss function, if you take any loss function, most of the loss functions are squared loss functions, right? And sometimes you also say cross entropy loss function or mean absolute loss function. You take any kind of loss function. So what is a loss function? The loss function is actually trying to identify how much your prediction is uh, correctly telling you about the target attribute. Is it right?
Yes, sir.
So what it is actually? It is trying to tell you the dependence of each other. So if the error is coming low, it means you are very close to predicting the things, correct?
Yes, sir.
So which inherently means that you are able to predict. So one feature is dependent on another. So any kind of loss function can be utilized here.
So like entropy is used in the decision tree, as you have also said, ki when we have used the entropy just to like at the time of creating the trees.
Correct.
So what exactly the like behind intuition of the entropy, or how we can able to explain that entropy is the uncertainty in the data?
Okay, so let's look at this mm, figure. Okay,
Yes, sir.
let me take you to my Excel sheet. Okay, can you see this Excel sheet?
Yes, sir.
Okay, great. What I have done or how this graph is made, let me try to tell you. This is the probability. So probability I have taken or I have increased from 0 to 1 with
Yes,
the
sir.
difference of 0.1, right?
Yes, sir.
And then we have taken entropy with the base E, with the base 2, and with the base of 10. Is that okay?
Sir, what are these base?
Log base.
Okay,
So
okay. Yes,
because
sir.
when you are
Fine, fine.
calculating the
Yes, yes,
entropy,
sir. Get it. ID3 algorithm of decision tree. Yes, sir. I get that.
it's okay. So let's just try to look at this. Here you can see the probability into log of the probability. So
Yes, sir.
minus that, and you sum it up. So that's the formula for entropy, right?
Yes, sir. Yes, sir.
So we are utilizing that with the natural base of natural or E, or with the base of 2 and with the base of 10.
Okay, sir.
So that's how we are trying. Now you can see here, if you have a probability 0 or if you have a probability 1, the entropy is 0. Can you see it?
Yes, sir.
This is the entropy. Y-axis, you are seeing the entropy, and the entropy is 0. While
Yes.
if it is only 50% probability, it is reaching to the maximum.
Yes, sir.
What it means, if you had a coin and you toss it, it is 100% uncertain whether you get a head or whether you get a tail.
Okay.
Only 50% chances are there that you get tail, and 50% chance for that you get a head. While if there is a case, or if there is a event which is 100% sure, there is
Okay.
100% certainty
Yes, sir.
with
Get
a
that.
probability 0 or with a probability 1, right? There is a
Yes,
100% certainty. You know that the sun will rise from east,
exactly, sir. Okay.
right? So there is no entropy in this.
Yes, sir.
Only
Get it.
entropy lies when there is some uncertainty. When the probability is actually half, the entropy is highest.
Always one. Yes, sir.
Okay. Okay. So does
Yes.
that clear your doubt?
Yes, sir. Exactly clear, sir. Thank
Okay.
you, sir.
Any other doubt? Anybody else?
So one more question from the ma'am. Sir, we the correlation matrix give all 0. So
Hmm.
if the correlation matrix gives all the 0, what
Okay.
does it mean?
First of all, correlation matrix cannot have all the zeros, because the variance with itself is coming in picture. And variance with itself coming in picture gives you the identity matrix at the max. So covariance matrix, whenever you are trying to find out, let's look at one more Excel sheet. Let me just take you to the one. Okay, so look at this. This is the correlation matrix, right? So, okay, I know that you might not be able to understand how this correlation is calculated over here. So let's just try to understand what is a correlation matrix. The correlation matrix contains on the diagonal correlation with itself, while the off-diagonal identities or off-diagonal items are actually considering the two different variables. Is that right? Is it visible?
Yes, sir. It is completely
Yes, sir.
visible.
Okay, so once you are actually finding out the correlation with itself, it cannot come 0. It has to be at least 1. Only the case where is though no variance even. So the case is like all the values are 1, all the values are 2, all the values are 3, all the values are constant. So in that case, your variance comes out to be 0, and the number or the correlation comes out to be NaN, not a number. And in such a case, there is no point in actually doing anything, right? So otherwise, you will always get a 1 here on the diagonal. The off diagonal things, if they are coming 0, which is very good. Why? Which is very good? In case of machine learning, and if you are talking about predictors, and if the off diagonal items are coming out to be 0, it means that there is no information shared between H and W. There are two attributes. Height cannot be determined by weight, and weight cannot be determined by height. So there is no correlation at all. So both of them are providing different information. Is that okay?
Yes, sir.
Any other question? Okay, should we go ahead?
Yes, sir.
Okay. Okay, let's come to the wrapper methods. Wrap is actually doing some kind of covering you want to provide onto something. So wrapper method actually goes with things as a whole. When we are talking about filter methods, they are not considering the communication between the two attributes. It is quite possible that two different attributes, when they combine together, they gives more information about something or the target attribute. So this communication is important. This communication should not be left out. This communication is actually sometimes plays a good role. So in such a case, we go ahead with the wrapper methods. So what are these wrapper methods? So that they take a lot of candidate sets of features. So let's suppose if you have 10 features, so you make different subsets of features. So let's suppose if you consider all the subsets, then that comes out to be 2 to the power 10 subsets. One of them is 5, I agree. So you can reject it without any question. But otherwise, other subsets are useful or in some way relevant. And out of these, all the subsets, you want to find out which particular subset is actually having good information or tries to tell maximum about the target attribute. And again, you want to know, okay, uh, how many features I should keep. So sometimes what happens is that you have a storage crunch, you have computational crunch, and because of that, you want to reduce your features. Now, reducing features in such a movement, you want to identify most non-informative, most redundant features, most useless features. So when you say useless, it might be still useful, but least useful. So instead of saying useless, it is least useful, and that's why you want to remove it. So in such situations, we go with the wrapper methods. However, wrapper methods, as I told you, like there are exponential number of subsets that you might want to consider or you might have to consider. In such a case, they are computationally expensive. Again, so in one way where you are able to identify, okay, this feature is not required, you want to remove it, and that's how you have saved some space, saved some computational time. But on the contrary, the wrapper method itself is going to take some time. So there is a trade-off. Wherever you fix it, it stays there. Fixing the trade-off is always a tricky thing. You have to hit and try and go do a lot of things. So let's just see a brief algorithm about a wrapper method. So you initialize the best performance to be 0 and the best set of features to be empty set. Then you consider a set S of different subsets. Make set S of different subsets ऑफ इनपुट फीचर एफ. सो जितने भी इनपुट फीचर हैं उनके आप कोई सबसेट ले लो और एक सबसेट लेकर के उसके एक फीचर को लेकर के आपने कोई एक सबसेट ले लिया जो कि सबसेट्स के सेट में है. एंड नाउ यू वांट टू फाइंड आउट द परफॉर्मेंस ऑफ दीज फीचर्स. You train over it, you predict it, and you get the performance. Once you get the performance, if the performance is better than the best performance, then you replace it and you keep the set. Otherwise, you leave it, you go for the next candidate item or next candidate subset for which you want to again try. Okay. I hope the background is clear. Now, the wrapper methods actually take advantage on this idea that how to choose the promising candidate feature subset. Promising means which might show better performance. So if we are trying to build in such a way, in the way that, okay, one by one we can add or one by one we can remove, and thereby we can actually choose a method to remove the least important feature or adding the most significant or most important feature one by one. So these could be different ideas to actually move ahead with the wrapper methods. So one of those wrapper methods we are going to discuss. So, okay, that is recursive feature elimination. So let's see how it goes through. So first of all, we train it a model, a base model we train on the data. Let's suppose it's a linear regression or a decision tree or whatever you want to take. You take it. Now, once you have trained on the data set, this particular model, you try to rank all the features according to the importance. For example, in case of linear regression, you always get some kind of alpha times x1 plus alpha 2 times x2 and so on and so forth. So alpha times your first feature, alpha 2 times of second feature, and so on and so forth. So now if some of the features are getting very low value of alpha. Low value of alpha means the magnitude of alpha is very less, near about 0. Then that feature is least important. It is not playing a good role in determining the class or in determining the value of target attribute. Since it is not actually contributing in determining the target attribute, we can think about removing it. So in this way, we make the feature ranking. So this is the important score. You can also find out the Gini index or the uncertainty, how much uncertainty you are removing. And if the feature is removing the least uncertainty, you might take it out. Okay, so these are the feature ranking ideas. And once you rank the features, you eliminate the feature with the smallest importance score. And once you remove that, you again go back, train the model with the current features, because one feature you have removed. So left out features, from the left out features, you again train the model, you again do the feature ranking, and you again eliminate. And you do all these things again and again until you get desired number of features. And once you get the desired number of features, you stop it there. And that is recursive feature elimination algorithm. Okay. Any questions in this?
Any questions from any participant? No, sir. Right now, no question.
Okay. Thank you. So the next one is the most important the method which is actually utilized in deep learning. So embedded feature selection. So which is also followed in lasso and decision tree. So lasso, we will see lasso, how lasso is doing it. We are not discussing here the decision tree, but let's try to discuss the lasso one. Okay, how it goes. But before going to see this, let me try to show you what does it mean by having a squared deviation or minimizing the squared error or minimizing the absolute error. Let's try to understand that thing. So for that, I'll take you to the one Excel sheet. Let me take you to the, oh, okay. Okay, so here, what I'm trying to show you, that this is the weight, this is height, and this is weight. So these are the original values of height and weight. Okay. Now, once you adjust means center adjusted means you assumed that the mean is center. Mean is your center. Mean is the origin. So 1.706 is now your origin, and you shifted the entire data accordingly. So if you subtract 1.62 and from 1.62 minus 1.706, you will get this value. Similarly, 1.72 minus 1.706, you will get this value, and so on and so forth. So you subtracted the mean. Out of each of such value, you subtracted this mean, and out of these such values, you subtracted the mean of weight, and you get this values. Okay. Now, if you consider the absolute value, you see it. This comes out to be here. And if you consider the squared deviation, so squaring this will give you this value. So initially, if you look at the sum of these deviations, the signed summation of these deviations is coming out to be 0. And also this is also coming out to be 0 because you have already adjusted the mean to be 0. Therefore, the mean again, if you find out of these adjusted values, will come out to be 0. But we are more interested in case of errors, we are more interested in the amount of error. We are not interested in the sign of error. So therefore, either we are interested in the absolute deviation or we are interested in squared deviation, because in both the cases, what will happen? the negative deviation and the positive deviation, both deviations are considered as error. Is that right?
Yes, sir.
Okay. So if you consider that, look at here, what's happening. The values which are very small, they are getting further small. The values that are big, they are getting bigger. Right? So here comes the problem. What the problem is, if you consider error, if you consider somewhere error, so let me just take you to the one of my sheets. If you consider a error, so let's suppose you have some error x, or this is y is equals to sum x1. So the x1 is your feature, and alpha 1 is the weightage of that feature, plus x2 alpha 2 plus x3 alpha 3. And let's suppose this is your model, and let's suppose alpha 4. So alpha 1, alpha 2, alpha 3, alpha 4 is actually giving us the contribution. So contribution of x1, the feature x1, the contribution is given by alpha 1. For x2, the contribution is given by alpha 2. For x3, the contribution is given by alpha 3. And alpha 4 is some constant that is required, bias term that is required to predict. So this is your prediction. This is linear model. Linear model. Right. Now, what in general we do? We have, let's suppose we keep a tilde here to say that it's a prediction, but the actual value is y. Now, when you want to find out the error, you go for y minus y tilde. So either you take absolute value or you take a squared one, y minus y tilde, and you want to take it a square one. So which one you should take? That's the question that we want to try to ask ourselves, because that will help us understand why this thing, the absolute deviation, might be sometimes good, and the square deviation can also be good in some cases, but it may also be bad for other cases. Let's try to understand it. So if you look at it, in case of most of the machine learning algorithms, there are two factors. So we are trying to minimize two factors. One is what we say we want to minimize the error. So we want to minimize y minus y tilde, some error function, some loss function, right? And we also want to uh, simplify the model. So sometimes we say that, okay, the weights or this alphas should be minimized. So which means like we want to minimize alpha 1, the modulus value of alpha 1 plus modulus value of alpha 2 plus modulus value of alpha 3, and so on and so forth. We want to minimize these also, because minimizing this tells you that that the value, this alpha 1 should be small, this alpha 2 should be very small, alpha 3 should be small. What actually gives you or helps you to keep these small values? The idea is, if you have in your feature some noise, if there is some noise, then it is amplified by this one. So if it is very large, the noise in this x1 will be amplified with a factor of alpha 1. So if alpha 1 is very large, the noise in x1 will be amplified, and accordingly your prediction will change, which we don't want. We want our model to be robust. With a small change in the data, with a small perturbation in the data, should not change our prediction. That's the idea, right? So we want to keep either alpha 1 square or alpha 2 square, or maybe the modulus of, so magnitude of alpha you want to minimize in some way. Either you want to take the squared one or you want to take the absolute one. That could be a choice. But yes, there are two things. One is the loss function. Another one is simplifying or keeping the contribution to be as small as possible for each attribute. So whether it is x1, you want to still minimize. Whether it is x2, you want to still minimize. So for every attribute, you want to minimize the contribution so that if there is error in the corresponding attribute, it should not get amplified to a higher level, right? Does that make sense?
So can you please repeat the concept why you have put the squared over the coefficient?
Uh,
Alpha squared.
You can keep anything. Basically idea यही है कि आपकी जो ये वैल्यूज हैं इनका मैग्नीट्यूड छोटा होना चाहिए. यदि मैं इनको माइनस में 10,000 ले लेता हूं तब भी तो आपका जो प्रिडिक्शन की वैल्यू है वो बहुत तेजी से चेंज हो सकती है. एक्स में यदि थोड़ा सा भी नॉइज हुआ और यदि मैंने उसको इससे मल्टीप्लाई कर दिया, इट विल बिकम वेरी ह्यूज.
Yes, sir.
राइट. सो आप चाहे एब्सोल्यूट लो चाहे स्क्वायर्ड लो, इट डज नॉट मैटर, बट समथिंग यू हैव टू टेक. कुछ ना कुछ तो आपको लेना पड़ेगा, चाहे एब्सोल्यूट ले लें चाहे स्क्वायर्ड ले लें. डज दैट मेक सेंस?
Yes, sir.
ओके, ग्रेट. सो आई होप किसी को ज्यादा हार्ड नहीं लग रहा होगा. मैं थोड़ा सा निटी-ग्रिटीज में जा रहा हूं. लेट्स ट्राई टू सी once again. So what happens is that we have a loss function for error. So let's try to this take xi for error, and there is some idea about the simplification or the smaller contribution from each of the attributes. So let's suppose I name it alpha. So some constant times a function of alpha. A function of alpha is, let's suppose we put some kind of this. Okay. So this is some function which may be a absolute value or maybe a squared value or whatever. So some function over here which actually tries to minimize the magnitude of alpha. So what this c actually represents. So if I keep this c to be very large, then a small change in alpha makes your this entire value to be large. यदि मैं c को थोड़ा मतलब c की हाई वैल्यू ले लेता हूं और अल्फा में थोड़ा सा चेंज होता है, थोड़ा सा बढ़ जाता है, तो ये c उसको बहुत ज्यादा एम्पलीफाई करेगा और वो कहेगा कि इस एरर को आप छोड़िए, इस एरर को आप ज्यादा मिनिमाइज मत कीजिए, आप इस अल्फा को मिनिमाइज कीजिए. सो सी क्या कर रहा है यहाँ पर, ये सी कंट्रोल कर रहा है कि क्या आप एरर को ज्यादा मिनिमाइज करना चाहते हैं या आप अल्फा को ज्यादा मिनिमाइज करना चाहते हैं, आप किस चीज को ज्यादा मिनिमाइज करना चाहते हैं. सो दिस इज कॉल्ड, समटाइम्स दिस इज कॉल्ड रेगुलराइजेशन पैरामीटर और पेनल्टी पैरामीटर. रेगुलराइजेशन पैरामीटर.
So is this thing we have done in the SVM when we have found the loss function? I think so.
Yes. एक्चुअली अभी हमारा जो फोकस है वो एक्चुअली ये थोड़ा सा कम है. हमारा फोकस है स्क्वायर्ड लॉस और एब्सोल्यूट लॉस के ऊपर जाने का. बट ऑल दीज थिंग्स कम टुगेदर इन वन पिक्चर. once they fit into, we will be able to tell that thing in a better way, how this actually help us. Okay, just give me a minute. Now just look at this. When I take squared one, so I can write squared one alpha 1 times alpha 1. So I want to minimize this alpha with the amplification factor of alpha. Now if alpha is less than 1, let's say it is between -1 to 1, it is further decreased. The magnitude of alpha or the magnitude of alpha 1 square will be further decreased, because यदि आप -1 से 1 के बीच की वैल्यू को स्क्वायर करते हैं तो उसकी वैल्यू और कम हो जाती है. अब चूंकि वो और कम हो जाती है तो आप क्या बता रहे हो आप ये कह रहे हो कि इसको कम मिनिमाइज करो, आप इसको ज्यादा मिनिमाइज कर लो, राइट? क्योंकि ये तो और छोटा हो गया जितना पहले था। सपोज कर लीजिए कि अल्फा जो है 0.1 था, तो अल्फा 1 स्क्वायर करने के बाद में क्या हो गया, 0.01 हो गया। तो अब आप इसको कम मिनिमाइज करोगे, आप कहोगे कि भाई ठीक है, इस लॉस को पहले मिनिमाइज कर लेते हैं अपन। लेकिन यदि ये अल्फा मैं 2 कर देता हूं, तो अल्फा स्क्वायर हो गया 4। तो ये कहेगा कि नहीं, आप इसको छोड़ो, पहले इसको मिनिमाइज करो, राइट? And because of this, what happens is that suppose if you have outliers means there are certain data points which are actually putting somewhere else. They are very beyond, highly beyond the normal data. Now यदि कोई डेटा ऐसा पॉइंट आपके पास आ जाता है जो बहुत ज्यादा दूर है, तो उस पर एरर भी ज्यादा आएगी, और उसकी एरर स्क्वायर्ड एरर होने से वो एम्पलीफाई हो जाएगी, और आपका सारा का सारा मॉडल का ध्यान उस एरर को कम करने में लग जाएगा. So thereby what it will do, it will try to make more promises towards outliers rather than promising towards the smaller values. स्मॉलर वैल्यूज पे उतना ध्यान नहीं देगा जितना आउटलायर्स पे ध्यान देगा, और आउटलायर्स को ठीक करने के चक्कर में वो अपना सारा का सारा मॉडल जो है वो खराब हो जाए, राइट? एंड दिस इज व्हाई you utilize ReLU function instead of any squared function for your activation, right? So sometimes we utilize the absolute ones, because if you take absolute one, what will happen? This alpha 1 is not there. So if there is an error of 2, this is only penalized, not this. So it is not amplifying itself, right? So that's the idea why we sometimes do not want to take squares. Does it make sense? क्या
Yes, sir.
किसी को कुछ पूछना है?
So one more thing, it is said that absolute function are not differentiable. What does that actual mean?
Okay. What do you mean by differentiability?
So like when we have finding the loss function related to the linear regression, so we not used to use absolute, we use these mean squared method to apply the gradient descent, and to optimize it we have to differentiate that loss function to like to compute the coefficient of that line equation. So at that time I have read about it ki absolute function are not differentiable, that's why we have used it. So but not get the actual meaning behind it.
So let me just take you again to this picture. Maybe I can tell you something about it. Differentiability is actually a mathematical concept about saying that how much smooth is your function. So if smoothness is like this is a smooth function, but can you say this is a smooth function?
I don't know, sir.
So smooth means everywhere you have a small change, only a small change is there. But here, if you look at it, suddenly your curve changes its nature from moving here to moving here. So there is a sudden change. So if there is a sudden change, then there is no differentiability. No differentiability. Are you getting it?
Yes, sir.
सो स्मूथ फंक्शन जो होता है, स्मूथ फंक्शन हर जगह डिफरेंशिएबल होता है, लेकिन जहां पर आपके बिल्कुल एजेस आ जाते हैं, बिल्कुल यदि आप शार्प एजेस की बात करते हैं, तो ये शार्प एज पे कहीं पे भी कोई भी चीज डिफरेंशिएबल नहीं होगी. ठीक है. सो
Yes, sir.
फॉर एवरी फंक्शन, इफ यू वांट इट टू बी डिफरेंशिएबल, you have to make it smooth.
Okay.
Okay. So this is how
Excuse me, sir.
I think. Yes.
Mrs. Sukeshi has raised her hand. She
Please.
might have some query. Sukeshi ma'am, do you want to ask anything? Let's it seems like he does not
Unknowingly,
have
she might be
yes, yes.
happening. Okay. Okay. So I think we are almost done, and I think we are running out of the time also. Uh, Let me just finish it. So basically, we have this term where we are looking at this uh, weight to be minimized in the absolute manner, not instead of squared manner. We are actually minimizing it in the absolute manner. And that is the most important part of lasso regression, because this helps you to identify or to shrink those weights which are not so important to zero. So the high magnitude, if you are taking, let's say 2, I just told you that if the error is 2, it is again amplified by 2 if it is squared. But in case here, it is not amplified. So whether it is an error 2 or whether it is an error 0 or 0.1, it is minimized with the same factor, lambda. Right. So in such case, what happens? Most of the experiments, most of the things shows that they turn out to help in reducing most of the coefficients to zero. And once you bring out these coefficients to be zero, most of the coefficients to be zero, you will remain with those coefficients, you will remain with those features which are actually contributing a lot. And rest of the features, their weights becomes zero. So they are not contributing and ultimately they are removed. So this is major idea about the embedded methods, wherein the model itself tries to identify which particular feature is important compared to others. Right. So that's the major thing. So the penalty parameter regulates how many features to be selected. So this lambda is actually helping it out. And the lasso is about least absolute. So absolute is going for this W absolute. So this word absolute is coming for that. Least means that you are minimizing the entire objective function. Shrinkage, because you are shrinking the weights and trying to select the features that are required for your model. So that is about least absolute shrinkage and selection operator. The model is sparsity. Sparsity हम कहते हैं उसी चीज को है जहां पर ज्यादातर चीजें जीरो हो जाएं, पर यहाँ पर हमारे वेट्स जीरो हो रहे हैं, and that's why we are saying that it is making model sparse. जब मॉडल स्पार्स होता है तो डेफिनेटली हम काफी सारा स्पेस बचा लेते हैं, क्योंकि जो फीचर काम के ही नहीं है उनको यूज क्यों करना, उनको हटा देते हैं. So वो हमारा स्पेस काफी ज्यादा बचा देते हैं. So sparsity in the model is always appreciated, and they also give the interpretability of the model, because कम फीचर्स हैं तो आप समझ सकते हो कि कौन सा फीचर ज्यादा कंट्रीब्यूट कर रहा है किसी चीज को बताने में, किसी टारगेट एट्रीब्यूट को प्रिडिक्ट करने में, कौन सा फीचर कम प्रिडिक्ट कर रहा है. And that's why the interpretability, explainability also improves. So any questions?
Any questions, participants?
Okay, so there are some books and papers that I've identified. If you people want to go through with them, you can actually take this presentation from Ashish sir. He might have the presentation.
Yes, sir, we would share this.
Okay. So if any question or any query if you have, please go ahead.
It seems like no questions from participants. Participants are encouraged to ask any kind of query, any question. So Dr. Kapil Gupta is saying good session.
Yeah, thank you. Thank you for all the participants for hearing and for getting this, for providing me this opportunity. I actually thank the Poornima Institute as well, and all the faculty members, those who are involved in this organizing this ATAL workshop. I hope the participants are benefited out of this session, and they can come to, they can directly approach me if they have some query. I actually appreciate the understanding of the things in general. So at any point in time, if you have any question, please come up.
Sir, Mr. Raghavendra Sharma is
Yeah, please.
asking, please share the book for further reading. Like we
Sure,
shown
I
one.
can share the slides. So slides are already shared with Ashish sir. So he will share again with all of you whosoever wants. So there are many books are available, and I will try to find more and put it on this slides. Thank you, sir. I hope.
Thank you, Kapil sir. Thank you very much for such an informative and uh, that hands-on practicing session. So many basic concepts you have covered. Actually, as our focus is on preservation of dialects, so our main requirement is that how to distinguish dialects. So based on
Yes,
that, this session focused on feature selection. Like
correct.
to preserve it, we have to first need to identify each kind of dialect. So
Yes.
I think this would be very helpful for all the participants in this perspective. Thank you so much, sir. Now, may I request all the participants to please turn on their cameras so that we may have one group photograph.
Okay, I think I should stop the presentation.
Participants are requested to turn on their cameras so that we may have group photograph for the technical session third. Okay, thank you everyone. Thank you so much, sir, for connecting with us, for delivering such an informative session, even in the evening times after your regular academic time. Thank you so much, and for your so many efforts.
Yeah, thank you. Thank you. Thank you. Such a kind words. And I hope more and more people actually they can directly connect me. I am actually interested in having an understanding about the concepts. This is my specialization. I am not focusing on the work that are recently done, but I am focused on the understanding the mathematical formulas, what they say. So at any point in time, any uh, student, if they want to come in, they can ask us. That's a great
Actually, I
thing.
want to also share with all the participants that sir has been making so many efforts from so many days, so that all the participants may get thorough information. Thank you so much, sir, for your all efforts.
Thank you. Thank you, sir, for providing the opportunity. Thank you.
Thank you, sir. Now I request all the participants to remain connected with us as we would have next technical session 4 on various applications of deep learning from Mr. Shreedhar Deshmukh at 7:30. So stay connected with us.
Welcome back, participants. I hope I'm audible, and Shreedhar sir has also joined us. So I would like to invite Dr. Kanta Gilani, Assistant Professor, Department of English, Central Sanskrit University, to introduce and welcome Mr. Shreedhar Deshmukh. Kanta ma'am, please. Ashley sir, unmute her mic, please.
Kanta ma'am, you may start.
Yeah, namaste, sir. Good evening. Thank you so much, sir. It's a pleasure having you here, sir. So,
Good
greetings
evening.
of the day. Dr. Sridhar, sir, is working as an assistant professor. Yeah, sir. Good evening. Of
Very
data
good.
scientist, NSB Academy, Bangalore. He has been a data scientist in Madlench Innovations Private Limited, consultant analyst with rich experience in industry and academia. He has his expertise in data and in business analytics, machine learning with Python, R, NLP, NER, TensorFlow, Django, HL, and more. He has many seminars and workshops to his credit. He has been playing an active role as a project team lead and technology guide, giving his lessons on technical management education. He is MSc and MTech from NMIMS Mumbai. He had his FDP on applications of machine learning from IIM Bangalore. Many certificates and training programs are to his credit. He has been convener to many conferences and workshops also. I welcome you from the bottom of my heart, sir, on this 6-day FTP program on preserving local dialects using multi-layer pre- perceptions for sustainable development of communities. It is really honor to have you here, sir.
Thank you very much. Thank you all for allowing me to speak something on this FDP. So today we all have gathered here for great FDP created by Poornima Institute of Technology. So so we'll start the already. I think since yesterday. The topics on deep learning and a few topics on uh, machine learning are covered, but still, I would like to take you through some applications. But first, before that, I would like to start with machine learning and why we require deep learning. And then I would like to take you to some the application of NLP with machine learning. Why? Because what we have developed when uh, I was working as a data scientist when we were classifying medical document classification, which is very much unstructured data. And after that, for the new so far new technologies in deep learning, as far as today's this thing is concerned, I have not worked more, but when we were working just 2 3 years back, so now there are a lot of advancements have come. And we worked on medical document classification on unstructured data. Even that this thing is there with me because we have sent it for patent also. And then I have that data set. I can show you how in industry that is a practical application uh, which we have worked. So that data set and that complete Python program also I can show you how we have classified the medical documents. Okay. So before that, I would like to start with the machine learning, and then we'll go, because deep learning is where it's the extension of machine learning. And in deep learning, already we have learned where we use neurons, and then we use activation function and input layers, hidden layers, the output layer. The hidden layers will carry the weights and then bias. All that we have learned almost. Okay, even today's session, before my session, it was a very good session where all mathematical applications, mathematical formula and applications have been given. So it was a very good session given by professor. So can I share my screen?
Yes, sir. Please, sir.
So in this session, I would like to take you first to machine learning. Then the best part is NLP, but because I was very much thorough in this, I worked on NLP, and then we go for deep learning applications. Why? Because why do we use deep learning? NLP is machine learning cannot handle the multi-dimensional data, so that is why we go for deep learning. Machine learning applications, industry, and deep learning applications are same. We use the huge multi-dimensional data. That is what even we faced when we were working.
Excuse me, sir.
Using machine
Sir.
learning. Yep. Yes, please.
Sir, yes, sir. Actually, sir, there is some echo and voice is unclear, sir, from your end. So, could you please check?
Okay. Just a minute. Hello.
Yes, sir.
Is it audible?
No,
Now
sir.
it is
Still,
audible.
it's audible, but not very clear.
Uh-huh. Just a minute. What is the problem? Hello.
Yes, sir. Now it is.
Hello.
I think it is now very. Now it is clear.
Now it is clear.
Yes, sir.
Okay. Okay. Thank you.
Thank you, sir.
Is the screen visible?
Yes, sir.
Okay.
Visible.
Okay. So to start with, like as everyone knows, machine learning is where the Arthur Samuel, a pioneer in the field of artificial intelligence and computer gaming, coined the term machine learning as field of study that gives computers the capability of to learn without being explicitly programmed, right? So how it is different from traditional programming? I'll just take out all this. So in traditional programming, what happens, we feed input program, and then so in machine learning, what will happen, we feed output. Why
Sir, again,
output
the problem is
is
arising. I think the network problem is there, sir.
just is it audible?
Yes, sir, audible, but
Just
I
okay.
think there is some network issue. Means voice is not very clear.
It's a network issue.
Yes, sir. Yes, sir. Now it is clear.
Now it is clear.
Yes,
Is
sir.
it clear now?
Yes, sir. Clear.
Okay. 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 So the terminologies that one should know before starting the machine learning, as we all know, That is model. A model is a specific representation learned from data by applying some machine learning algorithm. A model is also called as hypothesis. Hypothesis, which gives you the result, or hypothesis where statistics
Excuse me,
what
sir.
we think is we have achieved not. Pardon?
Uh, so sorry for
Yes.
interrupting you, but I think that when you are far from the screen, then voice is clear, and when you come near, I think there is some issue.
Okay. Okay.
It seems
So
like look. It seems like from here.
okay. Now it is clear.
Ah, yes, sir. Now it is clear.
Okay. Okay. So when we speak about the hypothesis, we have null hypothesis, we have alternate hypothesis. Statistically, when we speak a null hypothesis, we will consider null hypothesis and then we'll go for alternate hypothesis. If null hypothesis is, if we are consider the null hypothesis is the assumption that I am whatever I have, like if I suppose this is the true, then I can say this is a null hypothesis, and if I want to reject it, my alternate hypothesis should be true. That is which a model gives you the result, right? So feature is an individual measurable property of our data. A set of numeric features can be conveniently described as feature vector. Feature vectors are fed into to the model. For example, in order to predict the fruit, so there may be fruits like features for the fruit, like you have color, you have smell, you have taste, etc. A lot of things are there. So the target label, now target label is, now coming to your target label, which is the output of your machine or output of the model, which is giving you a target label. We will speak in machine learning, that is you have supervised learning and unsupervised learning. So usually in machine learning, and then we'll go for deep learning. Deep learning uses the supervised learning, where we have to fed into the data, and then the supervised learning algorithm, supervised learning data will be fed, and then we will have weights and bias will be given. So you will have an output of the uh, uh, deep learning. So why I'm speaking about the machine learning, target variable is the output of the your model. So training, now the idea is to give a set of inputs, that is features, and its expected output labels. This is in your uh, you are giving a training set to the your model, and then you are creating a hypothesis. Hypothesis is your nothing but your which is giving you a result, that is output. And prediction is you are predicting the data based on your training data set. So we have given, whenever you are giving a data set to the machine, or what model you have created, so you will be 75% or 80% of the data set is given for training, and then the remaining 10 20% or 25% will be kept as a testing set. And even after that, you can test the other different things to whether your model is giving accurate result or not. That is your prediction, right? Now coming to learning, types of learning in machine learning. So you have supervised learning, unsupervised learning, and semi supervised learning. So supervised learning is, now what is supervised learning? Supervised learning is when the model is getting trained on the labeled data set. Now what is labeled data set? Labeled data set is you have the data which are being already labeled. Like if I have given the images of the fruit, so already the images are given with the label. Banana is there, orange is there, and then you have any other labels are there. So here, like the data is given where it is showing the temperature is given, and then pressure is given, relative humidity is given. All these are data. The data is given where you have the label, the heading is given, that is attribute is given, that is called as a labeled data. Here user ID is there, gender is there, age is there, salary is there. So this is, now there are two problems are there. One is this problem and the another is this problem. Why these two problems are shown? This problem is doing something and this problem is doing something. This problem is a regression problem, whereas this problem is a classification problem. Classification problem means I am classifying my data set on the basis of the salary and age and female male categories. On the basis of that, so whether the person has purchased something on the online site, or if he is not purchasing anything. And here it is the wind speed. This is a regression problem. It is a multiple regression problem. So there are in supervised learning, we have things like classification and regression. What I have just now shown, two images, so classification and regression. So here, what is classification? Classification is, it is a supervised learning task where the output is having defined labels. It is a discrete value. It's not a continuous value. It's a unique value. Continuous value means you have multiple range is there. You have 1.2, 1.3. All these are continuous values, right? So for example, you have output purchase label 01 is given in the previous example. You have banana, you have all these photographs or images of fruits are to be classified. So in the example now, further what example I would like to give in classification, the actual machine learning, where what we have used for document classification, that is a kind of classification that I'll show you later. Okay, so here in the classification, what we are doing is, on the basis of data set, I am classifying whether that the particular element or the particular data belongs to that particular class. So we may have a single class, we may have multiple classes also. So we have multi-class problem. We may have single class where, or two classes. We have two classes, either 0 or 1. That is called as binary classes. Okay, and then like here where it used where the classification problem is used, usually it can be done through machine learning, it can be done through the deep learning also. Both does the same thing. Only difference is when we use nowadays, we have many different algorithms using deep learning we are going. Why? Because we have multi-dimensional data. Earlier it was not that, but even that time we have used deep learning. But why I still prefer some of the algorithms with machine learning, that I'll show you in my this thing. So when classification is used, it can be used in Gmail classification. What Gmail classification means, or you might have heard the spam and ham classification, where the spam mails come into your particular spam box. Why? Because Google has its own classification algorithm. What it does is, whenever you whenever you register your Gmail account, what will happen? You will be giving some preferences. So those preferences will automatically, those mails come to your mail ID, and there are some mails which come to your spam. Why? Because Gmail looks that it is out of your preferences, and then that is it goes to your spam mail. Even sometimes what will happen, your mail which is to come to your inbox, it comes to your spam because it doesn't identify properly. So it even sometimes it goes to your spam mail. So regression is used. It is what is regression? Regression is a supervised learning task where output is having continuous value. So continuous value is where it is a fractional value, right? Mathematically. So here what will happen, like the example given is, output is wind speed is not having any discrete value, right? But it is a continuous value. Here I can show you in the example, right? So this is all a fractional value. It is a continuous value. whereas discrete values are uh, uh, see, for the discrete value I can say that discrete value can be in your categorical also, discrete value can be in your the individual value like 1 2 3 4, all these are discrete values. Or even if I take a categorical where you have if I say 0 1, it's a discrete value. 0 1 means only individual value, it's a discrete value. Okay, now so can I ask this question, what is machine learning? So you can type in your text box. Is the PPT visible?
Participants, yes, sir. Yes, sir.
Yeah, okay. Okay.
Participants are requested to answer about the machine learning. What do you think about machine learning when it comes to speak
Pardon?
machine learning? Yes, sir. I'm asking participants. Means
Yeah, yeah,
like we
yeah,
are
yeah.
asking, what is the machine learning when it comes to here to there? You may write your answers in chat box.
Yes, correct. Many of you have given. Okay. Good, sir. Good, good. So now, examples of supervised learning algorithms. We have linear regression. We have nearest neighbor. We have Gaussian new Bayes algorithm. New Bayes algorithm is a probabilistic algorithm. It is used for classification. Also, it is used for it is used for classification. Then decision trees in regression. You have linear regression problems can be used with linear regression, multiple linear regression, and then decision tree also is a regression problem. You can use decision tree also for regression problems sometimes. Okay, and then support vector machines. Support vector machines classify the problems with the hyperplanes. It uses hyperplanes to classify the problems. Okay, and random forest is a kind of decision tree. It is, there are two types of trees, like one is decision tree and one is random forest. Random forest is a dense forest decision tree. Then unsupervised learning is the training of machine learning information that is neither classified nor labeled, and allowing the algorithm to act on that information without guidance. Okay, so here the task of machine is to group unsorted information according to the similarities, patterns and differences without any prior training. What will happen in unsupervised learning? In supervised learning we have a labeled data, right? So the data is images or anything is there. So the data is already labeled. We have heading, or even if we in a Excel sheet you can see that the heading is given. So if I want to classify something, I am, whether it is purchased or not purchased. But in unsupervised learning, how it will work? If I have given multiple images to the data, to the machine or to the model, and without labeling any of the data, what your machine will understand? Your machine will I would like to give an example here. It is best as for a kid, when we say, when we give some images, it may not understand what that image is, because it doesn't know what that image is. Then every day if you teach that kid with, if you show the banana and say this is banana, and then if you show some other image, it is apple. So every day if you are training to your kid, then one day if you just show the image, it will give you the answer, it is banana in his own uh, kiddie language, right? So like that, your machine learning or your system is also your machine, your model is a kid where you are going to train with multiple images. So what will happen if I'm giving a labeled data, then your machine understands, yes, the top labeled data is to be considered for this kind of images, and then I can classify whatever in different uh, uh, dimensional images are given, and then I am going to classify this.
Excuse me, sir.
But,
Sridhar, sir.
but
Sorry for interrupting you. Sir, maybe go for the slideshow view. Actually, it is in normal view right now,
yeah,
presentation view.
yeah, definitely. Yeah, unsupervised learning, where the if the label data, the data is not labeled, then what we will do is we'll do a clustering. Now clustering is nothing but we are grouping the machine, not the machine will group the items into different clusters, right? So what will happen, you can cluster the images in different groups. Group A has some images, group B has some images, group C has some images. Why it is doing means it is identifying with the dimension, with the size, structure, everything. So it is just identifying that particular image, and it is grouping that image into different classes. So that is clustering. And association, it is associating. We have learned in mathematics association. We are associating the nearest neighbor, nearest points, and then here we use a priori algorithm, right? uh, in one of the marketing project, there is one project is called as market basket analysis. You might have heard. Has anybody heard this market basket analysis? Can you please give? Anybody has heard market basket analysis? Usually it is not used in machine learning, but it is a part of machine learning. Market basket analysis is, see, where we use a priori algorithm or we use association rule here. So the association rule is we are associating. You might now what will happen in malls like Big Bazaar or wherever you go. So we might have seen there are combo offers. With 2 packs of bread you may get jam, or with 2 packs of bread you may get biscuit also. So there is a combo offer. Why the combo offer is? Because that combo offer is moving. So one product is associated with the other product. So people usually tend to buy that product because one product is the associated with the other product. It is moving with that product. It is not individually moving. Your jam is not individually moving, maybe but it is moving with your bread. So that is called as association rules. So that is a market basket analysis which is done in the data analytics. So clustering problem is where you want to discover the inheriting groups in the data, such as grouping customers by purchasing their purchasing behavior. And then association rule is, just now I have told, it's a learning problem where you want to discover rules that describe large portions of your data, such as people buy X. So there was a in US, I would like to give example here. There was a market basket analysis where done, where the uh, beer and diaper. Beer during the New Year celebration, usually from 25th to 1st in US, it was done with some big mall. This association rule was found, where The beer and diaper was a combo offer. Wherever the beer is purchased, the diaper is purchased. Okay, so that is the, it is associated with beer. Okay. Then unsupervised learning algorithms, we have k-means cluster algorithms, then a priori algorithm for association learning problems. Okay. Then we'll come to the semi-supervised machine learning. So to counter these disadvantages of supervised learning, where we have only labeled data, or we cannot use, if it is unsupervised learning, then we the unlabeled data is there, it will group into different categories. So the concept of semi-supervised learning was introduced. So in this type of learning, the learning algorithm is trained upon a combination of labeled and unlabeled data. So typically, this combination will contain a very small amount of labeled data and a very large amount of unlabeled data. In semi-supervised learning, labeled data is used to learn model, and using that model, unlabeled data is labeled, called pseudo labeling. Okay. So here, model with the labeled data and model with the both labeled and unlabeled data is shown here. It is showing labeled data, and here labeled and unlabeled. This is semi-supervised learning, and here it is supervised learning. It is data is labeled, and here it is semi-supervised data. Now coming to regression, so there are two types of regression. One is simple linear regression, multiple linear regression. We know polynomial regression. Then in machine learning, we use decision tree regression, random forest regression. What is simple regression? Simple regression models are used to show or predict the relationship between two variables. Like the best example for regression is, we have seen height and weight is the best example, where the height of the person increases, the weight of the person correspondingly increases. Or if we can say, if the rainfall, the measurement of rainfall is good, then the yield of sugarcane is good. That is where the regression comes into picture. So we can use regression. Regression is a supervised learning algorithm which works on the labeled data, and the formula for your regression, simple regression, is y is equal to b0 plus b1 into x1. X1 is what? X1 is here is, it is a independent variable, and whereas your y is a dependent variable which is to be predicted. And these are where you have usually in mathematics we write y is equal to mx plus c. It is it's a straight line formula, right? Then here it is intercept, b1 is intercept, and slope and intercept. b0 is slope, and here we say it as coefficient and constant, whereas in y is equal to mx plus c, m is your slope, and then c is your intercept. Correct. And then here what we say is y is a dependent variable which is used for prediction. This example is for carbon dioxide emission. This is multiple regression problem, where we have engine size, cylinders, fuel consumption is given, and then CO2 emission is found. So here, this you have multiple points given here, where Now your straight line is going with many of the, and it is joining some of the points on the, on your plane xy axis, and some of the points are away from your line, where the distance, it shows that there is an error between this your point, the actual which is predicted, and the distance between the unpredicted value. Why? Because it is away from your predicted value. Wherever you have this line is going, touching the points, all these are predicted values, where, and the points which are away from your straight line shows that there is an error between your predicted and the actual values. So this you must be knowing, in which category does linear regression belong to. You can answer this question easily, right? Which category the linear regression belong to?
Participants, please answer in the chat box.
Okay, so I'll continue. Then we have a
So one of the participants has answered supervised.
supervised. Okay, very good. The supervised learning. Now, using Python, if I want to use this linear model or regression, so then what we do is we have sklearn library from Python. It is an inbuilt library in Python. So from sklearn, we take linear model. Linear model is which gives you linear regression model, and then regression is a variable where your regression model will be stored. Linear regression model is stored, and then I am using the train X, where the training data is engine size is stored, and then train Y, where I am converting that values into arrays, and then it is stored into your train X, and then CO2, that is carbon emission, in train Y, and then regression fit. That fit, you are fitting that values into train X and train Y, and then you are printing the coefficients. This is your program for
Excuse me,
your.
sir.
Yes.
Mr. Yesh Katara wants to ask something. He has raised his hand.
Okay.
Yes, sir. You want to ask something, Mr. Yesh Katara? Okay, sir. Maybe mistakenly he has raised the hand.
Okay. 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 So now about the regression, I'll directly come to your logistic regression. Why? Because we have a classification problem. So now in linear regression, what is linear regression? What does it do? In linear regression, mathematically, linear regression is a problem where on the straight line the data points are to be fit. Then that straight line is drawn, right? So we can't use. Can we use linear regression for classification problem? If anybody say yes or no, can we use linear regression for classification problem? No. Okay, good. Why? Because not directly. Why not directly? Because it is, see, linear regression is fitting the data points on the straight line. So it means somewhere what will happen, I am going to predict the next value. Usually the regression problem is used for prediction of the next value. If I want to predict the height, weight of the person, if the height is somewhere 170 centimeters, so what will be the weight of the person of 175 centimeters? Using that data set, I can predict the next value. That is usually regression problem can be used for prediction, further prediction. And here, that is why we have a regression only in your this thing, in the machine learning, that is as logistic regression. Now what is logistic regression? This is also regression, but this is used for the classification. Now how it can be used for classification? This is called as a sigmoid function, where logistic regression doesn't use the straight line, it uses a sigmoid function. So in logistic regression, we have where it is used, it is particularly used for classification. It is a probability model of a certain class or event existing, such as you want to classify pass, fail, win, lose, or cat, dog images, any images you want to classify. So logistic regression is used. What will happen in logistic regression? Here I am showing you. Now there is a straight line drawn here. But what will happen? I will convert this into a sigmoid. Now, what is sigmoid? Sigmoid is like S shape. So S shape, what will happen is, here this is a y-axis and now have x-axis. So this what it is doing, this here you have a tumor size, and here this side it is malignant. Malignant is a cancer cell. So what it is showing means, for me is, if this straight line is converted into your sigmoid like S shape, what will happen at the middle, when your S comes here at somewhere here at the middle, that is 0.5. So here your y is starting from 0 and 1. It till 1 you have 0 says no, and 1 is where S. So your S shape, it is a regression only, but it is converted into sigmoid. And then in this sigmoid, what will happen? Your zero point 0.5, above zero point 0.5, I can say it is a malignant cell. That's a threshold. And above zero point 0.5, you all have malignant cell. It is considered as a tumor, which is a malignant. And below that, all I will consider it as a zero, because it is a tumor, is not a malignant. So I am classifying one particular data set, I am classifying into two halves, like whether it is malignant or, I am using kind of regression, but still it is not a straight line regression where it's a sigmoid function, it's a S-shaped function where it classifies. And here you have ROC or ROC curve, area under curve you will get, where your it shows how much your area is covered with true positives and false positives, that we can speak. So logistic regression is a sigmoid function. Here you have a formula for that, which is used for hypothesis representation. Okay. So this is your sigmoid function. So where your above 0.5, we will consider it as a 1, and below 0.5 is a 0. Then after this, the classification, because till linear regression, multiple linear regression, we do all supervised learning, and it is just used for prediction purpose. Here also we are doing prediction, but here we are classifying and predicting the values. So here also the value is predicted. One means you are predicting it as the tumor is cancerous or malignant, or it is not. So that's a prediction, but you are classifying into two classes, whether it is cancerous or it is not, malignant or non-malignant. Like that, we are doing it. So now come to your natural language processing, where we use text classification. So text classification is done through the natural language processing. You need a NLP library, natural language processing, and in Python we have NLTK, natural language toolkit. Using NLTK library, we will do the text classification in the Python. Okay. So what is natural language processing? And how do we go further with with the use of natural language processing for classifying any kind of documents? So natural language processing is an interdisciplinary subfield of linguistics, computer science, and artificial intelligence concerned with the interactions between computers and human language. So in particular, how to program computers to process and analyze large amount of natural language data. How do you do it? So NLP powers many applications that use language, such as text translation, voice recognition, text summarization. Now we use text summarization. In today's scenario, we are using, earlier we used TF-IDF, then we are using BERT. We have started using BERT, and then ChatGPT has come with the deep learning model, that is large language model. We are using chatbots are there. All these we are using in today's scenario. Earlier, when we started NLP with, we used TF-IDF. Even today also, TF-IDF works better. Why? Because what it does is it gives the word counts. So word vec is there. But now in today's scenario, we may not use word counts, as we have been using large language models for text summarizations. BERT is bidirectional algorithms are there that we are using for text summarization. Then text processing in NLP. What we do, how do we do it? So tokenization, dividing the text into smaller units such as words or sentences. So whenever we have a word or a sentence, what do? We divide that word into sentence into different words, or a collection of words, that is sentence. Then stemming and lamentization. What is stemming and lamentization? You are reducing the word to its base word or root word. Running becomes run. Okay, jogging becomes jog. So this is where, why we need this. Usually in document classification, we reduce the word to its base word, so that the classification becomes easier. For how it becomes easier, I'll show you in one of the thing. Then stop word removal. Why do I require stop word removal? Has anybody idea of why do we require stop word removal in your text classification? Why do we require? Can anybody answer? Why do we require? If anybody has gone through, why do we require stop word in any kind of text classification? Removal of the stop words. Now, what is stop words? First, I'll tell you. What is stop word? Stop words are nothing but the articles in your sentence, like a and the, or is, was, all these simple similar words or regular words. All these are removed. Why do we require that? Can anybody answer? In text classification, why do we require is, see, whenever we have a sentence of big sentence, and if you have many articles in that, and then you have all these regular words, is, was, grammar words are there. So what will happen? It will not give weightage to your sentence. What you want to classify, whether you want to classify this into particular class. If you have more articles, or you have more noun, pronoun words, or regular words there in English words are there in your sentence, it may not classify. Like suppose what will happen, uh, uh, if you like the patient is suffering from cancer, if I say the patient is suffering from cancer, then there are the is there and the patient is there, and uh, some other word is from is there. So these words may disturb in your this thing, classification. So I will remove all these things, and then I will remain with only three words, important words. That is, your the word is cancer and the patient. So this classifies that patient. This particular this thing is in your logistic regression. So it gives you more than zero point 0.5 base because it's a malignant towards, it is going towards one. So that is we require stop word removal, so it does not carry any significant meaning. Then text normalization, standardizing text, including case normalization, removing punctuations, then correctness, and then removing spaces from the word. All these are required because it doesn't carry any significant meaning. If you keep those words, so it will not carry anything, and then your there is a chance that your document gets misclassified. Okay. So here I have a small example which I can show. So now uh, this particular snippet, what it shows is I'm importing pandas, then I'm importing NLTK, which is a natural language toolkit, and then from scikit-learn, sklearn. Sklearn is a model. This is library in Python. So at sklearn feature extraction, there is a sub library, or feature extraction is a function of sklearn. What it does is we have two important things in your sklearn. Is one is for text classification. I'm speaking count vectorizer and TF-ID IDF vectorizer. Then you are using stop words to remove the stop words from your sentence. So here, count vectorizer is a way to convert a given set of strings into frequency count. It will count the frequency, how many times the word is appearing in your particular sentence. Okay, so now you have two sentences. One is text one and text two. Text one is natural language processing is a subfield of AI, and the tag is given for that. Tag is NLP. And the text 2 says computer vision is a subfield of AI, and the tag is given as CV. It is computer vision. So here the tag is given natural language processing. Why? Because I have written something, natural language processing is a subfield of AI, and then text 2 is computer vision is a subfield of AI CV. Okay, so using your program, so what we are doing is we have already imported the count vectorizer from sklearn feature extraction, and then in your CV is count vectorizer variable, where I'm importing this count vectorizer function. Then cv.fit. So in the cv.fit, we are fitting these two text sentences, text 1 and text 2. These two sentences we are fitting in these two text 1. Now what it will become, this text 1 and text 2 will become the list automatically. This become, because already we have included in the double quotation, and when I'm importing here, that's why it is given in the angle brackets. So cv dot transform text 1 to array. To array means you have to convert it to array, because your count vectorizer counts your arrays, and then it's a matrix. So y is cv dot transform text 2. You are transforming both the sentences, both the given sentences. Text 1 contains this particular number of words, and this text2 contains this particular number of words. It's considered as number of words only for it, because it is a sentence for me, but for computer it's a collection of words. Then your cv.get feature names. Then you have a panda data frame. So column wise index it will print. What it will print, then I am concatenating here. So see, df1 is where the your values are converted into a data frame. Why data frame? Data frame is a collection of, data frame is nothing but, in python data frame is nothing but your matrix. It is divided into rows and columns. So here on the column you have an index where your text one should be displayed, and all the values which are repeating, how many times the particular text is repeated, that it will show there. So here you can see this. I have printed this. See, I have concatenated this, and then I'm going to print your df of tag, NLP, and CV. So what it is doing, AI, computer, is language, natural, of, processing, all these are words from text 1 and text 2. And two tags are given here, NLP and CV. So what it is saying in this particular thing is, since text 1 does not contain words, computer and vision, hence their frequencies are calculated as 0, while other word the other words are present once, hence their frequencies are equal to 1. So its inability in identifying more important and less important words for analysis. So it will just consider words that are abundant in the corpus. And then TF-IDF stands for term frequency and inverse document frequency. So it measures, what it measures, it is it gives the number where, I'll just show you here. Is where Okay, I'll just show you in my Python. See here. Here, and I've closed. Okay. So here, that file, I think. See, maybe I have closed that file. Okay. See here, what will happen? I have one more file where we have different uh, words are there, and then that file. Uh, I enjoy learning machine learning. It is so here. What is happening? What TF-IDF is showing here is, which has a less frequency count. So that is a very important word for your classification, document classification, which has a very less frequency given. So that will be considered as a very important word for your document classification. See here, I can show you in this program. Okay. So here I have taken a news group data, and then one more data set I have taken that I'll show you, the real-time data set. Okay. See, I'll take the real-time data set only. See, in this program, I think everybody can see this program. In this program, I'm using NumPy, and then I'm using a regular expression, and then I'm using um, NLTK, and then I'm using data set load files. This load file function is used to load the complete files. Here I'm not passing the single texts, whether rather I'm passing the complete files, text files. So now what we are doing here in this project, we do not have an Excel file where we have kind of words collected. We have multiple files, collection of different files, which comes with your PDF, and then those files are converted to OCR. OCR means optical character recognition. All text files are created. So I can just show you. I cannot send this file, but I can show you uh, this file. Okay. See here, in this class, we have different classes here. So we have classes. This is complete medical document classification project where we have different classes. We have admission record, and we have anesthesia. All these different files are there. Then we have chiropractic records are there, and then we have CT records are there. All these CT records are there, and then we have diagnostic test records are there, and then we have the acknowledgement of the patient, accident scene investigation, police report will be there, the affidavit of the patient will be there. All different classes, different records are there. So now why I'm saying this is now if I take all these different folders, what I have to do? I have to classify, right? So what kind of classification? See, what kind of problem it could be? Can somebody tell? If I take this, whether it is supervised learning or unsupervised learning. If I take all these folders for classification, whether it will be a supervised learning or unsupervised learning. Can anybody? If I want to convert these files into classification, so it will be a supervised learning. Why? Because for all these folders, we have different class names, right? So already the folders containing different files have different files are there, patient files are there, and these files are named as it's a discharge summary, or it's a CT, it's a consent, chiropractic, then assessment, anesthesia record. All these are classes, different classes are given. So using Python classification program, what I'm doing is I'm using a scalar data set for loading files. Then I'm using NLTK corpus stop words. Then sklearn feature extraction dot text, which I use for count vectorizer. And then I use TF-IDF vectorizer. And then after this, we are using different algorithms. Like before that, I'm using a scalar model for train test split. Then random forest I'm using, and then I maybe use decision tree also. So then I am using this files I have stored, and then see here, this particular thing is I am cleaning the data is pre-processed here. So data is from this. Now what will happen? This your complete data read from your files, and it becomes a list. So when it becomes a list, it is stored in your particular variable, the length of that particular list is read, and then it is stored in your particular variable. Then that, using regular expression, I'm trying to clean all that using regular expression. Why, if there are any white spaces, that should be removed. If there are any characters, small characters or individual characters are there, individual small characters or large characters are there, which does not have any meaning to that particular document, that is removed. And then remove single characters, then substituting multiple spaces. If in between two words you have multiple spaces, so that is removed through your this regular expression plus s. Then regular expression, removing prefixed lamentations is done for where. And then first what I'll do is I'll convert your word capital to lowercase, and then your lambdatization is done where your word is converted to its base word, and then I will have a list where the complete document will be stored. So after this, what we are doing is we are using count vectorizer. So count vectorizer, which is used to convert to your array. All these words, collection of words are converted to into array, so that your count vectorizer counts the number of frequencies, number of words, how many times those words are appearing in your text. So that is counted, and then once that word count is done and that is put into your list, then after that I'm using xtrain, xtest, ytrain, ytest. Then I'm using train test split, where your x and y. So test size here you can increase. Here just I've given 0.4, 40%. You can increase to more also. So you can increase to, I'll increase it to 7.7, 70%. Okay. Then classifier, I'm using a random forest classifier. You can use decision tree classifier. You can use logistic regression classifier. Any classifier I can use, that is, it is it comes with your sklearn. Then the number of estimators here, the number of leaves or number of trees I am giving, you can mention the size or you can leave it depending on the data set what you have. After this, what I'm doing is classifier fit. I'm fitting my x train values and y train values, and then I'm using y predict and classifier dot predict x test. So x test is used to predict the, already the classifier is being trained using x train and y train. For training your classifier, I am using x train values and y train values, and then I am predicting my x test values using the classifier using predict function. So here you have confusion matrix, y test, y predict. Confusion matrix is confusion matrix is where you have true positive, false positive, true negative, and false negatives. See, it's matrix where true positive, false positive, true negative, false negative. So what will happen? I am uh, trying to predict more true positives than the false positive. I am trying to reduce the false positives. Why? Because what will happen if the false positives numbers increase? So if would like to give an example here, if it is in medical terminologies or healthcare projects, your accuracy of true positive is more important. Why? Because if your prediction for cancer detection, if your false positive is more, then whatever you have predicted, there is a chance that your prediction is misclassified, it is wrong. So that chance may be there. So we have to reduce the false positives here. So the confusion matrix prints your true positives, false positives, and then classification report, accuracy of the uh, y test and y prediction. Then I am using a pickle here. Pickle is where it's a file where your classifier is stored, and then using this pickle, I'm again testing on individual any of the individual file which can be given. So that is taken from any of the file and it is to be predicted. So here I'll just run this. I'll try to run this program and I'll show you. It will take some time. Why? Because uh, it will have multiple classes. So it is a multi-class uh, function. Sorry, multi-class classification. Why? Because we have multiple classes. It is not a binomial classification. We have only where you have only two classes. Here you have in this library, in this folder, you have many different classes are there. So we cannot just say it is a single class or binomial class. It is a multi-class class. It will take some time. Yeah, already I have here. I can show you here, which is already uh, done. See here, this is output where all these classes are classified. So most of the classes have 100% classification, and some of the classes are classified in 95, 93%. Your CT is classified to 93%. So documents, how many, this shows supporting how many documents are there in that particular folder. So this gives your classification report. So, anybody has any questions on this till now?
Any question, participants? You may ask any query, whatever you have. Sir, I think no question right now.
Sir, can I ask something?
Yeah, please.
Yeah, sir. Actually, I was thinking like, sir, person who is not much familiar with the machine learning and person who is from language background, how can the person connect with dialects with this machine learning? Because nowadays translation is emerging, sir, and we need
Uh,
to work on the Indian languages as well. So how can we have a hand on this?
See, now because of there are GPTs have come and BERT has come, it has become easy with the deep learning. But still, I believe you should start with the machine learning because you will understand the NLP, natural language processing, with machine learning. Because what will happen here is you will be using decision tree, you will be using logistic regression, or sometimes you may use support vector machines, which with the hyperplane it classifies different classes. So it is better you start with the machine learning and then go with the deep learning for any kind of natural language processing project, because deep learning will take anyhow it takes multidimensional data, and it can do on its own, because deep learning is where uh, automatically the data is trained, because of you have multiple hidden layers are there, and you can just give your data on its own. It gives, the only thing is you have to adjust the weights there. So the data will be taken, it will learn on its own, and then it will give you result. Maybe the result is more accurate than your, because GPTs have come now. But still, I believe if you learn on machine learning with the natural language processing is good.
Yeah, sir. Thank you so much. And sir, how can we have like easy access to dialects through the
Because
PC?
yeah, pardon.
How can we have easily we can access these dialects easily through these
uh,
machine tools? I mean, you are working on these tools because these are very much deeper and higher level of. So I would like to connect this with the language part, with the literature part. How general a common language teacher going into the classroom can connect these tools to that tools like this.
no, I didn't mean. So if you go to class, you will be using Python, right?
Yeah, we
Uh,
can.
See, in Python you have a library called sklearn, and you can see what will happen. I can just show you one more. This thing is there.
Sure, that's what
See,
I'm seeking just. If you could connect with the language part as well, that would be great help. Thank you.
yeah. See, see what will happen here if you have Python, and if you are good in your sklearn. uh, sklearn is already there. Sklearn, where you just, only thing is if you go to sklearn on your Google, then it will give you libraries. You can understand. First you have to go through what sklearn feature extraction function does, what sklearn count vectorizer function does. If you go through all these in your class also, you just go through it, and then you can explain those in the library itself. It is given how you should use sklearn count vectorizer, how you should use sklearn tf-idf vectorizer. So what will be the result of count vectorizer, how it counts the frequencies. So everything is given in that sklearn library. So if you go through that libraries, and then if you go to class, so easily you can take any kind of text files, or even if you are like if you take a sentiment analysis project which is on your Flipkart or anywhere. So you may have a CSV file where you are converting, you are finding the like the restaurant classification, which restaurant is good, depending on the people who have given their feedback. Maybe the food is good and the place is awesome. So that I can say the restaurant is very good. But sometimes people have given positive and negative both feedback. The restaurant is good, the food is good, but the environment is not good. So that what count vectorizer does, why I am saying we should use machine learning, because deep learning automatically does it. But here what will happen, the word not good, there it is the TF-ID of frequency for that particular word, because which is not frequently used, the weightage will be more for that word. So that classification is always good. Why? Because then I can say that particular sentence is saying that even though I have some people have said good for that this thing, but there is the environment or the what do you say, the maybe the cafeteria is not good. If I have used not that negative word, shows it is the restaurant is not good. Okay.
Yes, sir. Thank you so much.
Yeah. Yeah. Thank you very much. Anybody else? Okay. So here I have one more I can show. There is some in my. It should be a practical thing rather than PPT. I would like to show you some more classification problems. I have some real time this thing. Okay, no problem. Now coming to your this thing. This is about your machine learning and even the text analytics can be used for sentiment analysis, text classification, document classification, any kind of these things. So yesterday we have already, I think the professor has given more on deep learning. So why do we require deep learning? Now, till now I have explained about the machine learning. Now, why do we require deep learning? Why? Because there are some limitations on machine learning. Machine learning is of traditional machine learning, not good for handling. As I have told, it is high dimensional data, difficult to do feature extraction. So what will happen in machine learning? I am extracting features. See, now in this project, what I have shown just now here. See here in this project, what we have done, we have read the files and then we have predicted. But before that, I need some vocabulary for this. If without the vocabulary or without the features are extracted, I cannot compare my features extracted with the current file. Because if I am classifying any of these files into some classes, I need some vocabulary which is already there. Because if my vocabulary words are matching with this, that is what I do in count vectorizer and TF-IDF. So some individual unique words are there which are matching with the with these classes. So that first I will create a vocabulary using chi-square test. So that chi-square test can be done using your Python program, and then I am extracting the features from all these different files, and after extracting, I'll create a vocabulary, and that vocabulary is called as first feature extraction. And then in machine learning, first I have to do the feature extraction, and then I am using that feature extracted vocabulary with the current prediction. Then I'll then programmatically I'll create a pickle, and then I will try to predict all that. So in deep learning, what will happen? Why that is why. Just a minute. Okay. Yeah. So in deep learning, what will happen? The limitations of the machine learning is it's a traditional, and it cannot handle high dimensional data. So difficult to it is there is very difficult for feature extraction and object recognition. And deep learning is computationally expensive, but it is capable of handling high dimensional data. That is why the people now are not using machine learning. But for learning your concept, how your features are extracted and how your model is classifying the documents, machine learning is very good. But because deep learning, what it does is it automatically extracts the features, because you are adjusting the weights, you are adjusting your bias, so that it should extract the unique features from images. Because in image, what will have, you have multidimensional data, many types of images. There is a difference between when we use textual data and image data. In image data, what will happen, you will not have uh, what do you say, text or the word vectors, where the vectors are created with the patterns, right? So with this kind of patterns, it is going to identify. So that kind of projects will be difficult in the machine learning. So that is why we go with the deep learning problem, the deep learning algorithms. But even machine learning can do it. You have OpenCV, where you can extract, you can read the image, and then you can read the image, you can extract the patterns, and you can understand. But it takes more time, and deep learning can do it easily for you. Okay, so here machine learning is a base for deep learning. Basically, machine learning is a base for deep learning. So linear regression is learned in machine learning. How? See, in linear regression model, it provides an equation to compute the value of y. Just now we have seen y is based on x. X is an independent variable and y is dependent variable. So we have a linear regression formula of y is equal to mx plus c. Yes.
Sorry for interrupting you. Sir, actually, uh, we are running short of time, so may I
Yeah, yeah.
request?
Just 5, 10 minutes. I'll finish. 5 minutes.
Thank you so much, sir.
Yeah, yeah, yeah. Definitely. So here, now I'll come to your this thing, applications of machine learning. So applications of machine learning and deep learning. Even machine learning can solve these problems. Machine learning can solve natural language processing. So applications of deep learning, natural language processing is very good understood by, because only thing is in multidimensional data, deep learning can do much better, because you have GPTs now, large language models are there, BERT is there. So using all these natural language, it helps more to natural language processing. But for teaching and understanding, machine learning is better, what I feel. Okay, so applications of deep learning, natural language processing, and then speech recognition, and then image recognition, then self-driving cars are there. Nowadays we are living in AI. So where deep learning is used, it is used in healthcare, robotics, customer experiences, sentiment analysis, in many ways. So machine learning, all these, I think it is yesterday only sir has given. So why, what I wanted to tell you here is, this formula you must have seen somewhere, where we have seen this formula resembles our multiple regression problem, right? Here we have a multiple for this, where we have multiple regression, a1 x1 a2 x2, and then you have a intercept. So same is where it is replaced with the weights, and the independent variables. So we will, and then this B is bias in deep learning. So we will adjust the weights in deep learning, and then the bias is adjusted so that you are able to extract more features, more unique features to classify the problem. That is what we do. It's called as perceptron in the deep learning. Okay, so this is called as activation function. Then W is a weight, B is bias, F is activation function. So neural networks leverage sigmoid neurons, which are distinguished by having values between 0 and 1. So 0 is either it is classified or not classified. 1 is classified, 0 is not classified. So I think this all is yesterday it is being taught. I don't want to repeat. So anybody has any this thing, or I can complete this.
Does anyone has any query? No, sir.
So I have completed my this thing. If anybody has anything, they can ask.
Does anybody wants to ask anything? So I think no one has a doubt or query question. Sir, Raghavendra Sharma ji wanted to ask, sir, from where he can learn practical machine learning and deep learning.
Practical, now there are a lot of sources available online also. But now if you go to GitHub, you will get good even your Kaggle is there. Lot of these things are which for teaching purpose. You can get lot of resources, and then you will get code also. But the only thing is we have to understand how it is working, and then whenever you are using scikit-learn, go to scikit-learn library. Its own scikit-learn library of Python. So there it complete information of scikit-learn of every function is given, how feature extraction is done, what get feature name is done does, and then what it does, all these uh, uh, instrumentals. So all those can be learned from the libraries, scikit-learn libraries. For teaching purpose, that is good. You should go to say scikit-learn library only. You will get a lot of information. How count vectorizer works, how TF-IDF works. Because even for deep learning, we should understand what TF-IDF does and what count vectorize is doing, or particularly for text classification.
Dr. Aisha Rafi has raised her hand. Ma'am, kindly ask your query. Dr. Aisha Rafi.
Uh, as a faculty in English, I will look into the possibilities to implement these. See, there is one more thing in scikit-learn. There is called as pause tags. Pause tags means which gives you the English language noun pronouns, which gives you positive and negative words. So if I am running some program, I think I have that because I have to search it. Pause tags gives you the positive and negative words from the. It has its own library. in Python. So that gives you, if I say today I am not feeling well, so that sentence, your result will say you are negative. And if you say I'm today I'm feeling good, so it says uh, your sentence is positive. So pause tags can be taken into consideration in your English language.
Sir,
Any
it
other
would be
question?
yeah, sir. So
Yes,
it would be
Antamal.
of great help if you could share important tools which we can relate with the linguist part or language we can use in the classrooms.
Yeah, pause tag is one, and then there are in scikit-learn you have in text classification you can say the count vectorizer and TF-IDF vectorizer, which reduces the your common words like even your noun, pronoun, and articles. It removes, and it gives only the words which are required for your classification of that document. So that you can tell.
Right. It would be of great help if you could share the link in the chat box.
Yeah, yeah. I can send the program of POSTAG later. I can send to Ashish sir a program of
Sure.
POSTAG that you can use.
Yeah, sure, sir. Thank you, sir.
Sure, sure.
So participants are expressing their thanks to you. Any other question? So it looks like, sir, there is no question from any participants. So on behalf of the Department of Applied Sciences, Poornima Institute of Engineering and Technology, I would like to convey heartfelt thanks to you for taking time as some institutional work, some visits are going on or about to happen in your institution. Even after that, taking out of time in the evening hour after your academics and delivering and explaining so many concepts, making participants hands-on practice on Python, real-time examples. So it has been a wonderful, great session. I think participants have learned so many concepts and new things. Thank you once again, sir. Thank you for your all the efforts. Now, may I
Thank you
request
very
one?
much for giving me this opportunity to express whatever little knowledge I have, because in today's scenario, we cannot say that I know everything. So now the BERT has come, large language has come, GPT has come. A lot of things are if you, even if you are 6 months lagging, then you are very much far from the machine learning and deep learning models today in today's scenario. So if I have learned something, but the base is very important, what we have learned in machine learning, that what I say is, even in teaching we should give the conceptual thing in machine learning. We should make them perfect in machine learning, because anyhow deep learning automatically it does. The data set is given, you have only thing is you have to adjust the weights and bias, so it does everything. Because already you have BERT, you have different algorithms are there. But in machine learning, students will understand how I am going to do, why this result has come, that they will understand.
Yes, sir, correct. So again, my thanks also goes to the AICTE for providing this platform so that various concepts can be shared, exchanged. So now may I request all the participants to please turn on your camera so that we may have one group photograph in this technical session. All the participants are requested to turn on their camera so that we may have one group photograph. So thank you all of you. Thank you, sir, once again. Uh, Thank you all the participants for remaining
Thank
connected.
you all for your patient listening. Thank you all.
Okay, so thank you so much, sir, once again. Now, all the participants are requested to fill the feedback form shared on the group so that attendance can be monitored as this can be filled up to tomorrow 9 a.m. So I think all of us may leave now. Good night to one and all.
Thank you very much.
Thank you, sir. See you soon again in some another lecture.
Thank you.
Thank you.
Thank you very much.
Excuse me, sir.
Yes, please.
One of the participants, Dr. Samajan, has raised the hand. Ma'am, do you want to ask
Okay.
anything? I think, sir, by unknowingly the hand has been raised.
Okay, okay, no problem. Anybody has any questions, they can ask.
Could you please share, sir, your email ID or contact number in the chat box? So if anyone wants to
Yeah.
remain
I'll
connected
just send.
further. Thank you, sir, for sharing the email address.
Thank you. Thank you very much.
Okay, sir. See you, sir.
See you, sir. Thank you very much. So can we leave?
Yes, sir. Please, sir.
Yeah, sure. Thank you.
Thank you once again.
Thank you.